This video will follow along with your Topic 2 review for Algebra 1. In Problem 1, they're asking you to graph equations on a grid. Remember slope-intercept form, and it tells you the b value is your y-intercept. Be sure to pay attention to the sign so you can know if it's positive or negative. The m will tell you the slope. Remember, fractions aren't always so bad if the slope is in a fraction, because we think of it as rise over run. Slopes, if you recall, if you're reading from left to right and it's going up, the slope is positive. If it's going from left to right and it's going down to the right, it would be negative. A zero slope is a flat line, and we recognize these equations as y equals a number. An undefined slope is a vertical line. We represent these equations as x equals a number. Go ahead and give problem 1 a try. For problem number 2, they give you a picture of a graph and you are asked to create an equation. Now you can pick whichever equation form you prefer. Recall, slope-intercept is helpful if you know the y-intercept and you know the slope, or you can count the slope. Point slope is helpful if you know or can count the slope and you have a point. Recall, the point is visible in this equation with this value here at the end for x1 and this value here at the end of the y's for your y1. It also will be helpful to remember that if you were trying to make an equation with the point 3, -5, it would actually look like y plus 5 equals a slope times x minus 3. The value of the y looks as though it's changed to the opposite because you had a -5 and it goes to +5, or the 3 becomes x minus 3. That's because the equation has the minus sign built in. So maybe you want to make it in that form. Standard form is best for if you know the x and y intercepts. You could work backwards and create that equation. So go ahead and give number 2 a try by looking at the graph, identifying some key features, and creating an equation. One last thing to note, it's always helpful to look for where this line actually crosses grid points. You wouldn't want to use one that crosses lines in the middle of the squares. For questions number 3 and 4, they're really focusing in on that point-slope form again. So, for example, we know that m is right here before the parentheses in this equation, so we'd say our slope is 4. The point, this is our x value, we'd have our 7. Our y value is the 2. Again, realize that it looks as though the sign is opposite. So on number 3, you're asked to pick the equation in the point-slope form that goes through -3, 4 and has a slope of 1/2. Go ahead and select which equation you think that is and explain your reasoning. Once you finish, it's going to ask you on number 4 to identify the slope-intercept form. Now remember, that's the y equals mx plus b. In order to do this, it's a pretty easy process, so let's use our previous example up here. I will multiply that 4 through and get 4x minus 28. And to get my y all alone, so it will look like slope-intercept, I'd have y equals 4x minus 26. Go ahead and try 3 and 4 now. For problem number 5 on your review, it asks you to graph an equation in standard form. Remember, standard form is very big on identifying the x and y intercepts. And here's how we would do that. If you had an x value of 0, meaning you wanted to replace this x with 0, you would then continue to solve for your y value to find your y-intercept. The 0 part is gone. And so I would find that dividing by -5, my y value would be -3, and I'd have that on my table. That means I've found my y-intercept of -3, and I could plot that on the y-axis. Now once I found the y-intercept, I can flip-flop it and put my 0 in for y and substitute it in. That means the y part of the equation will be gone, and I'll be able to find my x-intercept. By dividing by 3, I can find that x is 5. That is my x-intercept. And so if I go to my x-axis, I will cross here at the 5. You will proceed to then just connect your 2 points, and you've graphed the line. Go ahead and give number 5 a try. And remember, if you ever needed to create a different form of the equation, now you could count your rise over your run, and you would also know your slope. For questions number 6 and 7, they're really focusing again on this standard form and creating equations in standard form. The x and the y always represent 2 variables that you're discussing. Maybe it's chocolate candy and fruit candy. Maybe it's number of turtles and number of fish. Whatever the variables are, always look for the information. They might tell you what variables are represented. So in this case, I do note that x is going to be the ball caps, or y is going to be the t-shirts. Once you know those variables, be sure to place the numbers or coefficients that go with them in front of those variables. And another big hint is the last number, the c value if you will, is always the total or the final amount. Try number 6, creating your standard form equation, and use it to solve number 7, trying to see if Paxton could really buy 5 caps, how many t-shirts would he also be able to purchase? In problem 8, we're focusing on the parallel and perpendicular lines. Parallel lines have the same slope. That means they'll never cross. So for example, they would look like this. Sometimes we use the symbol that is given there to represent parallel lines. These 3 lines over here in our little white box all have slopes of 3. Therefore, we would say they're parallel. Perpendicular lines, on the other hand, they do cross, but they cross at 90 degrees or a right angle. It's important to see here in our diagram that when lines are perpendicular, it could be like a vertical and horizontal line, such as your x and y axis when you graph, but they can also be slanted a little. We will note that this line going up to the right, again, we remember that's a positive slope. So if this line's positive, if they're going to be perpendicular, it's a given fact that the other line will have to have a negative slope. So we would say that they have to have opposite signs. The other unique relationship is the slope, or fraction maybe if you will, must be flipped. 5 over 3 is flip-flopped to give 3 over 5. That's how we note if 2 slopes are actually perpendicular to each other. So on problem 8, they're going to ask you to create a line that is either parallel, perpendicular, or neither to a given line. Now, it's not always easy to tell the slope if it's not in point slope, or say like this one over here, slope-intercept. Sometimes you have to plot the intercepts and count the slope, or it might be in your best interest to try to solve for y by itself, because after all, slope-intercept is probably our favorite form and the easiest to see the slope. It may be noted that some of your easiest ways to create lines that are parallel or perpendicular to another line are with point slope. Trying this example from your packet, we wanted a perpendicular line to y equals negative 1/4 x. So our slope is negative 1/4. That means our perpendicular slope, and remember this is the symbol for perpendicular if you haven't used it before, we would change the sign from negative to positive, which you don't have to write but you can, and flip-flop the fraction. So really our slope is 4. By using point slope, here's my point, x is 1, y is 7, I can simply fill in that y value, fill in my slope, and fill in my x value. Now, if they wanted it to be in slope-intercept form, of course I would have to multiply through and add my 7 to get 4x plus 3. But by starting with point slope form here, we don't have to think about the y-intercept. We can just plug in our point and make sure our slope is perpendicular. Finally, these 2 lines in yellow and orange down here, they ask if they are perpendicular or parallel or neither. So I can see the slope in my orange equation as a negative 4. I want to check if this graph has the same slope or a different slope. So I will go ahead and solve for my y. By getting a y all by itself, I'll have it in the form of y equals mx plus b. So 2y equals negative 8x plus 10. And if I divide everything by 2, if you do it to one side, you have to do it to everything on the other side, I will get an equation of y equals negative 4x plus 5. I can see now that the slope matches the orange slope. Therefore, these lines would be parallel because their slopes are exactly the same, and they have different y-intercepts. In this last example, that might be helpful, a parallel line or a perpendicular line. If they're supposed to be parallel to the negative 2/3, then the slope will be negative 2/3. If it's supposed to be perpendicular, it would be a positive 3/2. And if you were to create the equation, again, your best bet is to go with point slope because my point is right here. So y plus 5 equals my slope of negative 2/3 times x minus 3. Whereas my perpendicular line would be y plus 5 again, but now 3/2 times x minus 3. Go ahead and give number 8 in your packet a try.